Hi, my presentation's on optimal shot sequences by court position for different player types. The industry partner is Tennis Australia and Trobe University. So I'm going to play a video to hopefully illustrate the problem a little bit. Up the top there, you've got Stefanos Tsitsipas. He's about to hit a backhand middle cross, and then he hits a forehand into the net. Now, I guess the question is, where should he have played the final shot? Was the final shot error caused by poor shot selection, any of the shots before? And if you're going to advise him about best point construction to maximise his chance of winning the point, what would it be? And the answer to that is it depends. There's a whole lot of factors that go into determining that. So court position, player grips, previous shots, surface, score situation, a whole lot of other things. And I guess what my project is aiming to do is to look at shot combinations and see if we can get closer to answering that problem. Now, it's not going to go all the way, but hopefully it moves the needle a little bit closer. So I'm going to run through some of the research aims and past research reliance. A little bit of this is a recap for those that were at my previous presentation, but hopefully not too much. I'm going to talk about some key techniques and design decisions that were integral to the project. And then I'm going to dive into some of the interim results, some of the areas to explore in the future. And I'm going to do that in a little bit of an interactive way, so you engage with the data a little bit, and you also see some of my thinking, thought process in getting to some of the outcomes. Obviously, it's interim results, and I stress that a lot more analysis is required once the full data set is used. And as part of it, I've embedded some views from the dashboard that's been built for the end user, and hopefully you can see how someone would go about using the dashboard in a practical manner. So in terms of the research aim, the importance of shot sequence is highlighted. It's in a rally, so I'm talking about ground strokes here, and from different court positions and for different player types. Now, my understanding of the problem comes from working with not only players at the top of the game and coaches there, but also all the way down to the grassroots level. And I know that there's a lot of, I guess, an appetite to know about shot combinations, or knowing more than, I guess, the immediate shot in terms of what are the better patterns. Now, a lot of that's been anecdote driven, and I'm really wanting to introduce something that's a little bit more research back, a little bit more scientific to answer that. Now, it's not to say that past research doesn't exist. In fact, there's some really good papers that I rely on as foundation to my work. But in a nutshell, going into them, they've lacked the detail to answer the full breadth of the question that I'm looking at. And also they've neglected using some of the more sort of technical variables, which I think will help answer this more from a high performance perspective. So as part of my work, I've introduced some new variables, some technical variables, which I'll go into. I've derived, hopefully, a more representative player cluster that coaches can buy into. I've introduced new court tessellation, or new court segments that are more aligned with the modern game. And finally, the output of this is not just a paper that someone can read. There's a dashboard, an interactive tool that allows coaches, players, and other analysts to dive into the data and interrogate it in their own way. So I mentioned some of the past research that I thought was foundational. Now, there's two papers in particular that I relied on a lot. So the Winegar and Co. paper looking at elite volleyball and using market basket analysis to look at patterns that worked at a high performance level in elite volleyball. That was foundational to my work. I also looked a lot at Widener and Co. So they looked at spatiotemporal data in tennis, and they used association rules to look at good patterns. Similarly, I relied on a couple of papers for more of the methodology and the process, more than the final sort of the resultant findings. And two of those papers include the Zhu and Gomez paper, which looked at clustering and different methods to evaluate clusters, cluster sizes, and that was something that was important for me as part of the clustering work that I would do. Equally, there was a really good paper by Doug Eng and Dave Hagler, and they were looking at backhand grips in particular, and what I relied on was the process that they used to classify these backgrounds, so using high definition images to classify these the player grips. And finally, there's some really good papers that I relied on context. Now, I've only put two on the screen, but there was a whole lot more that's been really important for me to think about the results and analyze them. One of the ones that's was recently tabled, I think it was last year at the Sloan Sports Analytics Conference, value in decision making and shot execution in tennis. And that was a really important paper for me to read and think about, and certainly something that I have front and center when I'm going through some of my results. So in a nutshell, I guess my project is about optimal shot sequences, so using affinity analysis, market basket analysis for that component, court positions where I've derived, I guess, new court tessellation segments that are more aligned to the modern game, and finally using unsupervised learning to come up with, I guess, a more representative player cluster, which I think more coaches will be able to buy into. In terms of the sequence of how this project was done, the first component was the clustering, and once that was done, applied it on to the spatiotemporal data and applied sequential market basket analysis on top of that. So I'm going to play a video just to give you an idea of, I guess, segments and clusters, because I know this can be overwhelming, so hopefully this visual aid will help. So we're looking at the player down the bottom there, Sasai Zheng, and for the project, importantly, we're looking at ground strokes. A serve and return is excluded. I might just pause it just there. So the first shot that Sasai Zheng hits, she hits it from segment 5, she hits a backhand up the middle, and then she hits a forehand inside out. Now that second shot in that first chain becomes the first shot in the next chain. And she is also hitting that from segment 5. And then she hits a forehand inside out, and then finally, the third chain, she hits a forehand inside out. She actually hit that one from segment 2, and then she hits a backhand up the middle. So that's an idea of, I guess, the chain and the segments where the chain initiates from. Now there's two data sources, well, two sort of, and I'll explain that. So first one's coming from Tennis Australia. There's data from two players, a lot of data from those two players. If you're interested, it's Serena Williams and Roger Federer. And then there's technical data that's scraped from ATP, WTA, ITF websites. And finally, some of the technical data. So what I'm talking about technical data is, player grip, so the forehand grip, the backhand grip. So importantly, the top and bottom hand for two-handers, and making sure I've picked the dominant hand in particular. Now that was done using two approaches. So I worked with a high-performance coach who helped classify the top 100 ATP and WTA players, and also developed a computer vision solution, so using a deep learning, a transfer learning model to classify this automatically. Now, I ended up going with the manual approach using I guess the high-performance coach's eyes. That being said, the computer vision model, I think, is an area that can take this further, and I'll talk a little bit about that in the improvement section later on. So you might ask, why do we need to cluster players? Well, there's a lot of different players, so naturally grouping them has some importance when you're talking about results at a high level. And the other important thing, players are different. Now, past research has looked at clustering in tennis now, and I guess the limitation with some of that is it hasn't factored in some of the technical variables like grip. So what I wanted to do is to introduce a lot of those technical variables, which I believe will make the clustering more applicable to competitive tennis, high-performance tennis. So what's the benefit? Well, if you're able to do that, incorporate variables that are important to tennis, it's likely to get more buy-in from coaches. One of the really important things coming out of it is to deal with limited sample size of certain players. So an example of that could be, let's say you've only got one match of Astra Sharma in your data set. If you know Astra Sharma plays a certain way, similar to other players in a cluster, you can actually infer the results by looking at the cluster as a whole. And I just want to remind people that in this project, the clustering, the importance is really to look at where differences in court position in terms of players playing. So front and center of my clustering was that. In terms of clustering algorithms, went through a few different ones. So k-means, k-modes, K prototypes and different types of hierarchical clustering. In the end, I went with the K prototypes approach. Now, there's a number of evaluation techniques that I use to work through this in terms of the optimal size selection for clusters. I think the silhouette coefficient, the knee elbow method, they were really important for the K prototypes algorithm in particular. And I think with all the results, I'd certainly tempered it with the domain expert, as part of the discussion, because they helped, I guess, look at the players in the different clusters and seeing if it was warranted having another cluster added or not. Now, I just want to show, I guess, how the K prototypes algorithm worked, because it was one of the reasons why we ended up picking it. If you have a look here, so basically at a certain height, the K prototypes algorithm, with the data that we fed it in, it put players into the one cluster. So at a certain height, it didn't really look at any of the technical characteristics. I've got forehand grip here, but equally if I put backhand grip or some of the other technical variables, it would do the same thing. And that intuitively made sense. It made sense talking to coaches that players at a certain height, once they reach that height, and it's different thresholds for the men's and women's game, but once they reach that height, broadly the way they played was very similar. So it was K prototypes did that the best. Now below a certain height, then it started looking at the grips and some of the other technical characteristics and using that to differentiate between players, and that not only worked well for the top 100 for ATP and WTA. When we did spot checks of players ranked 500 or above, 1,000 and above, even in juniors, this appeared to work the best. One of the more challenging parts to all of this was actually trying to name the clusters. Now, it's not as straightforward or to do this succinctly, because you're no longer just looking at height or weight or forehand grip or backhand grip. You're looking at a lot of these variables that the algorithms use. So it was challenging, but I'm hoping coming up with right-handed players with extreme closed forehand grips or something like that is a little bit more interpretable than R3 ATP. One of the other design decisions that I wanted to make early on, and this was informed a lot by having the benefit of working for a number of years with players at the top of the level, but also in college tennis and recreational tennis as well, just to know that I guess the existing literature and the court segments or the court tessellations didn't seem to align with the modern game as well as it could, and in particular it wasn't useful for me to use in this project to work out the different shot options from different parts of the court. So it was really important that I sat down with a lot of coaches in doing this, a lot of different domain experts, to come up with a court tessellation or court segments that felt aligned with the modern game, and I felt would provide some good context to the results that I'm going to come up with. Another really important decision that was required at the very start was the level of detail to use for the shots. So what I mean by that is, could have been at a very high level, looking at just forehand to backhand chain, or could have been at the other end of the spectrum and been very detailed, looking at a forehand top spin range of 3,300 to 4,000, speed of 135 to 140, being really specific on the direction. Could have been that level of detail. Now in the end I went with a compromise somewhere in between, which in my opinion gives the benefit of both, where you've got some of the directional shot type information, which is important, but you don't make the analysis too cumbersome. The hero of the analysis is the market basket analysis, which has its origins in retail, where you're looking at product combinations that are purchased together. In my case, we're looking at shots that occur together. The association is important. The importance of sequence is something that I look at using various evaluation metrics, and ultimately I want to know how playing a particular sequence impacts the probability of winning the point. So get to the results. I guess running my code through and doing the sequential marker basket analysis, and basically for each segment, each cluster, I'm getting around 182 combinations. So it's overwhelming to try and unpick it. And a number of questions, I guess, front and center while I'm going through it. Firstly, how do I get rid of the noise? There's too much there to deal with. What's the best way to reduce the number of chains I'm looking at? Want to know what's actually associated. Want to know that the certain shots are actually happening in the sequence that's required. And importantly, I want to know that these shots are happening because it's intended, it's related, not just because it's happening at random. And then looking at what's actually better. So judging that against, I guess, a long-term and a short-term reward. How does it perform against some of the heuristics and baselines that we're aware of? So on the right there, I've got I guess some of the metrics that I've used and set to help unpick those questions. I'm not going to go through all of them, but I'll highlight a few of them which I think are important to help unpick this. So reducing the noise was really important. Support was the main one that helped me do that. Basically, support measures the frequency of an item set happening in a data set. What I mean by that is, how often a backhand middle and forehand middle occur together. The higher the support, the more frequently that combination happens. Now, I've set support at 2.5% in this, and it's based on, I guess, knowing all the different shot combinations that are available and looking also at, I guess, the data that I've got. Confidence is another really important one. I'm going to rush through that in this case, but it was also used to help bring down some of the rules. Lift is a really important one in marker basket analysis, and it's not looking at just if things are associated, but it helps unpick if something's happening at random. What do I mean by that? Well, a player may hit a lot of backhands up the middle, or they might hit a lot of forehands up the middle. It doesn't necessarily mean those two shots are associated or that it's been deliberately played. And lift can help answer that sort of randomness question. So a lift of 1, no relationship. What I'm looking at in terms of my project is a positive lift number, and the higher the better. An example of lift would be a lift of 1.8 means it's 80% more likely than it happening at random. The other important question that I needed to unpick was, do the shots actually happen in a sequence? The Kamakura paper on sequential marker basket analysis was really helpful with this. They had a number of new metrics that they introduced, importantly gain and relation. I won't go through the maths there, but the relation classifications that were important to me were whether shots were complements or they were happening in that A to B sequence. And then I guess getting to the results section, I'm looking at not only points that are won eventually, but I want to know the difference between shots that are won immediately, lost eventually, lost immediately, and then I want to compare it to baseline, so I guess heuristics or things like that. So any shots hit from a segment, is the chain better than that? How does the chain compare to if I was looking at high-level shots like a forehand and a forehand? So they were things that I needed to consider. To try and help sort of unpick that and maybe for you to go on the journey that I guess that I had to go through and I am going through whilst going through the results, let's have a look at this dynamic table. So the results here include data from all clusters, all segments. It hasn't been filtered at all. Up the top there, you got forehand inside in and forehand cross. Now we see that frequency of chains happening 51 times. And if you scroll to the right there, you see when that chain is played, 64.7% of the time the point is won. So that's factoring in the whole of the point. Now that could be one way of thinking about it, but if you want to know, I guess, what the benefit would be of winning the point immediately and what was the best chain for that, and you filter it, you've got backhand middle line and backhand line. Now that's I guess, one way to look at it now, that combination doesn't do as well when you're looking at the point overall, but when you're looking at immediate success, it's great. You might actually take a really conservative view and want to know chains that, when you play the chain, you don't lose the point immediately. So again, if you order the table based on that, you've got backhand, inside out, forehand, middle, cross at the top of that list. So that's, I guess, some of the challenges as part of this. And the way to address it, you can use a weighted per point outcome calculation, where you've assigned points that are won immediately or lost immediately a weighting. It doesn't have to be symmetrical. And in terms of the dashboard itself, I actually give the user the ability to weight the reward and the penalty, and that will adjust the scores for each shot chain. Now, importantly, just highlighting, I guess, that previous point. Now, for the research findings and paper, ended up going with some discussions that I've had with high performance coaches and domain experts, talking about what they believe the value is of winning a point or losing it immediately, and gone with a figure of 1.5. Now, I'm going to talk about it in improvements, but I think there's not a lot of science to that number, and that's something that can certainly be improved. Now, 1.5 may be right for certain players, but there's a lot of different player types, and I think there's an opportunity to improve that going forward. In terms of the results, I'm going to focus on segments 4, 5, 6, 7, 8, and 9. It's not to say I won't talk about the other segments. I'll certainly touch on them as part of context to some of the results, but the main focus will be those middle sections. And you might ask why. One of the reasons is there's this diagram here that I see a lot in coaching blogs and manuals and trading guidelines, and I don't necessarily agree with the zones where they've been sort of drawn, and that it's applicable to all players, but I like the states in there. So, for instance, the defensive state, you're reactive, so you may not have the shot chain options that you do in the neutral or the aggressive state. And similarly, in the finish state, you've probably got a clear path to ending the point, so you're probably not thinking about as many options. Whereas both the aggressive and neutral state, it's fair to say there are more shot options available, which lines up, I guess, with that middle section of my court tessellation. Also, running through the data, the Hawkeye data, it's clear where the action is, it's happening in the middle, makes sense to focus on it. So, I thought I'd give you guys a bit of a look at the dashboard, one of the views anyway of the dashboard. Now, technology can be a bit of a pain, so let's hope it behaves. So let's select segment 5. And again, working with this, some of the things that I'm looking at immediately is, okay, how many chains are being played from different player classes? I noticed that R1 and R3, those clusters have a lot, and it makes sense because that's where Roger Federer and Serena Williams' data is. But it's good to see that there's a lot of chains observed for some of the other clusters as well. So another thing that I was always looking at whilst unpicking the results are the differences between the men's and women's game. So if I select the WTA, and have a look at the high level shot chains, so I'll select segment 5 again. You can see quite quickly that on the WTA, at a high level, the chains are pretty similar in terms of usage. Now I'll switch that to ATP. So the men's tour, and when that updates, you'll see there's a big difference from segment 5, so that middle part of the court. The male game is very forehand centric, and you can see the most dominant chain is the forehand at a high level, forehand to backhand, which is yeah, I guess some of the differences in the male and the female game at that top level. It's interesting to see that plays out when you're looking at the detailed chains. You'll see a lot more sort of forehand centric shot chains in the men's game. This is, I guess, I think, anecdotally and initial sort of thinking of this, I think there's no surprises in that, but it's nice to see that play out in the data. In terms of looking, I guess, at the results in a tabular way, and also just looking at, I guess, some of the interesting results that came out, and some of the ways that I had to think about making myself comfortable with the results. And this is a good example here up the top of this for segment 5. So applying some of the minimums to lift, to constriction, leverage, things like that. You get these results. So for 13 chains, so this is the backhand line, forehand line from player cluster R3 WTA. There's 13 chains observed, and then straight away hits me, whoa, 84.6% when that chain is played from there for that cluster, the success. And then I also see 0% lost immediately. This chain looks amazing. But immediately I'm questioning it. I wasn't too surprised with the points won immediately, because it's a high risk pattern. There's a reward element to it, so yes, I can understand why that would be high. But the other two numbers were very interesting, particularly as I said, it's a high risk pattern. You're often going over the highest part of the net. I didn't expect it to be that high. So the way I would go about sort of unpicking that, certainly had to go back and look at the vision. That helped get an understanding of how those chains came about. And I guess for the audience that might not be as familiar with tennis, a little bit of an example of a backhand line, forehand line would be this, where Serena's just hit backhand line. In this one it's a forehand line. Often it's actually a lot closer to the sideline as well when she hit it. But yeah, that's a bit of an idea of what it looks like. Look at the vision, and then the other way was just, okay, let's have a look at those results, see if we can see why it's come about. And a way to do this is to use a different view in the dashboard, the shot chain view. And let's just wait till that loads and select backhand line, forehand line. And remember, we're looking at that R3 WTA group in particular. So here's backhand line, forehand line. First thing I'm looking at the overall clusters, and I can see, yes, the clusters with Roger and Serena have that chain the most. And you also see that in terms of the chains hit, Roger's hitting that combination 36 times in the data set, Serena's hit it 30. But it was the R3 WTA cluster that was the most interesting. So let's select that to try and sort of dig a little bit deeper. So selecting that, I can see that that chain is played from a number of clusters, but best success looks like it's from segment 5 when you're looking at some decent numbers of it being played. It's not as successful from segment 4. So that's interesting to know. But what we cared about was segment 5. So those 13 chains in that table. And just to see who's playing it, well, it's Serena Williams. She's played 12 of the 13 of those chains, and Belinda's played 1. So it's very hard with, I guess, that level of data. The sample size isn't enough to draw massive conclusions across the board. But what you can maybe look at and investigate further is, okay, Serena Williams seems to play that chain well from segment 5. She doesn't play that as well from segment 4. Is there any way, I guess, can you make sure that if she's going to play that, or that she's forced to play that from 4 a little bit more? And the other extension to this is, okay, she's just played that first shot from 5. How can we make sure she doesn't get a chance to hit the forehand line on that second shot? Because we know she's good at, the results are pretty good. So they're things you can think about. Showing that table again now, applying the weighted results. Again, you can play around with the filters. So this is where the result weightings are defaulting to 1.5, but you can certainly change that. So if I were to change the reward element to being a lot more, the order might change. Now, not all of them will change, but you can see some of the shot chains are now a bit better than they were before, and some are a bit worse. An important way for me to, go about answering some of the broader questions that I had starting the project about, different players playing differently from different segments. You can use something like this. So this is a table that shows the shot chains that have a positive score or positive use. So when you play them, you're more likely to have a good result. And selecting, court segment 5 in this, you can have a look at some of the differences in terms of shot chain options available. So this R2 WTA group, so bigger right-handed, bigger frame right-handed female athletes, they from segment 5, they've got a lot more shot chain options than this semi-open forehand WTA group in R3. Yeah, some interesting observations. The forehand inside in and the forehand cross, generally a good combination, but only used by men. Two cluster groups really dominate the use there. There's not a lot of immediate success when that's used, but it certainly had, that long-term or eventual success. An interesting observation from segment 5 was the male players did better if they had a forehand. They did better if they spread on that, so either using the forehand cross or going forehand line. Whereas if they hit the backhand first there, it was actually better for them to go up the middle, probably focusing a little bit more on a depth-based game as opposed to spreading the court. The backhand. For the WTA athletes, or the female athletes, it was generally better for them to play up the middle for both. Now, slight variations for the different playing clusters, but broadly at a high level that seemed to hold true, that statement. Again, early data, we need more, but I think that's an interesting insight so far. Similarly, looking through the results, it was important to compare it to baselines. So two of the baselines that I'm showing in this table. So the first one is, what's the difference playing a forehand line, backhand cross, comparing to just playing any two shots from that segment, and wanting to know that the actual shot chain was better compared to that sort of baseline. And secondly, is it different to playing at a high level any forehand backhand combination? And again, thinking about all of these things as well when you're evaluating the results and deciding to use them or not. Probably pressed for time, so I won't go through this in a lot of detail, other than to say this segment 6, so on the right hand is forehand corner, just having a look at the shot chains that seem to be, across the board available to players. Select that. And for most, so not all of the player clusters, but for most of the clusters, the forehand cross, forehand line combination was one that had a positive yield, and I guess that's something intuitively made sense, but it was kind of nice to see it play out in the data as well. So overall, and still obviously working through the data that is yet to come, but overall, looking at one of the questions, did certain players play better from segments? And the answer, I think, is yes. So not only did they play better or worse from particular segments, I found the clustering worked pretty well in terms that players in a cluster seemed to play similar, and players outside of the cluster played differently to those in other clusters. So initial findings are very promising there. An example would be, taller players with single-handed backhands, or even female players, open grip players, played better from central parts of the court, so segments 5 and 8. Whereas, extreme grip players, even two-handed grip players, generally played a bit better from deeper. And I mean better in the sense that they had more shot chains that had a positive yield. And in general, I think male players, and this is almost true for all the segments except one playing cluster, where starting the point with a forehand, the shot chain with a forehand, was better. It wasn't a big difference in the female game. So in terms of improvements, there's some key ones that I think will take this analysis to the next level, and I think you need 1,000+ matches, and you need at least 15 matches from more than 3 players from each cluster. I think that will give the sample size the confidence to be able to use this, I guess, more. Better shot valuation. Now, I talked about, when we were talking about the rewards or penalising eventual and immediate, the importance of coming up with something that was a little bit more robust. And I think that's an area that needs a little bit of thinking. And one idea that I had was you can actually tie maybe the shot chain being used to changes in court position. So court position of the player hitting the ball, court position of the opponent. And if you can tie it to that, then you might be able to evaluate the shot chain a bit more better. Scaling for future players is really important. So the computer vision solution that I used, which was using a transfer learning model, the validation accuracy, I wasn't comfortable enough with it to use. Now that's something that can change with more sort of data sample, using a lot of different augmentation techniques, even moving away from using images to using moving clips to do the classification. And I think in order to scale and to be able to add new players into the data set, this will be the way to do that. Other things to really think about: pattern robustness, something I talk about a lot, and I think it's important with the shot chains as well to think about the diminishing value of a shot chain being used. So the more you use it, it could lose some of the benefit. Equally, to extend this analysis to serve and return, to think about speed and spin, think about the quality of the opponent's shot, the positioning of the opponent as well in this analysis. Now, in terms of the dashboard as well, just to make sure there's it's factoring in the different user groups. You've got your analyst group, you've got your coach group, you've got your player potentially looking at it, you've got academics, researchers. They're all consuming the data differently, so to be able to build views and make it easy for those different user groups to use it, it will be important. And finally, I really think this could become a great deep reinforced learning sort of problem. And what I mean by that is if you can set up the environment to mimic sort of the human physics and the human environment, the rules of tennis, have that sort of built in, and that you can introduce the spatiotemporal data. You've got the sequence sort of data that you can also introduce. You can play around with the reward function, and then get I guess the true AI in reinforced learning to try and work through this, and you'll have a lot of what if scenarios, and I think this is the way it goes forward. Improves and you come up with shot combinations that are even better using reinforced learning. But that's the end of the presentation. Hopefully you enjoyed it. If you have any questions, please feel free to raise them now. Great, I can see a couple of questions coming through. Look, one of the questions there is asking what happens when a player doesn't exist in the data set. How can you sort of use this analysis to answer that? So one of the things I've done in the dashboard, and I'll just switch to it. Basically, if a player's not available in the data set, so I guess in terms of process, first thing you'll do, you look for a player. You look to see if we've sort of got sort of data for them. If we don't, then there's a button there that takes you to, I guess, a can't find player section, and it has a different view where you enter in some of the details of the player. So let's say this hypothetical player is a male player. They're right-handed. Let's say they've got a semi-western forehand grip. The dominant hand on their backhand is continental. Let's say they're two-handed, and let's say they're 188 centimeters tall, 80 kilos. And based on those selections and using the clustering, the K-prototypes clustering I guess, the variable importance sort of given to these different characteristics, it's saying that the player belongs in this cluster. Now, not sure if you recall from the presentation how I said at a certain height, it doesn't really, well, the K-prototypes algorithm really didn't care too much for the technical characteristics, to say it crudely. So let's example that. So if I select 200 centimeters for the player, basically they're going to sit in this cluster, and even if I play around with I guess the different grips, play around with I guess backhand grips as well, it doesn't make a difference. But if you have a look at at a different height, then suddenly some of these other things play a little bit more of a role in determining which cluster the player belongs to. Now, let's go select something else, and you'll see, I guess, the algorithm working out where they sit. Now, what you do once you know which cluster this player belongs to, you go back to the home page, and then you can use any of the views to I guess look at that particular cluster. So I think they were in R1 ATP. If you select R1 ATP, now I guess the dashboard, the views filter based on those selections, and you interact with the data as if it were any of the other players. So you can use all the different views in the exact same way as if you had the player in the data set. Importantly, just to remember, you can sort of do that with even if you've got a limited player sample. So we've got 15 matches at Serena and over 4,000 shots tracked. But let's see, a player like Sasai Zheng, for instance. So I'll just play that. We've only got one match. We've only got 550 shots from her. Again, it's probably better to use the player cluster, whatever view that we're looking at, rather than just using the data for Sasai Zheng. Hopefully that answers the question. Yeah, and that second question's an interesting one that you often sort of see. Coaches wanting to know what happens next, what if we force a certain action. So that question around if they want the first shot to be a backhand or a type of backhand is an interesting one, a relevant one, and one that the dashboard can address. So let's just go back to that landing page. And let's look at shot chain detailed page. So here you can force the first shot in the chain to be a specific shot. So if we wanted all the backhands, let me just select all the backhands. You can, if you wanted to be backhand cross, you can just select backhand cross as well. But I think the question was around backhand, and now I guess all the chains start with the backhand, and I guess the whole view is filtered based on that, and you can interrogate the data in that manner. So it's an interesting one. You can do the same thing with the second shot. So if you don't mind what the first shot is, but you want to make sure that last shot is a forehand up the line, you can interrogate the data that way as well. This is using a slightly different filter, but if you wanted to make sure that last shot was a forehand, you can select any of those options with a forehand as the second shot. And I'm just looking at ground strokes here, but yeah, equally, if you want to look at drop shots and other types of shots in your chain, you can select them. Hopefully that answers your question. Yeah, that's a good question. I think so. That question was around how do you deal with certain players being I guess better players, and potentially the chains available to them are not available to other players in the cluster. I guess my way of sort of answering it, the gold standard is if you have enough data on a particular player. So that example of, Serena Williams, where let's say, I think it was 15 matches. Let me just bring her back up. Yeah, so you got 15 matches. Let's say 15 was enough, and we were happy with that. The gold standard is using that individual data. So when I'm looking at the shot chains, when I'm looking at all the different views, I can comfortably have a look and select Serena Williams and do the analysis based on Serena Williams. So I'd select Serena, and everything would sort of be based on that. Now, that's not going to be available for all players, and then there's a situation where you need to know who's in specific clusters. So it's important to know, okay, in this R3 cluster you've got some elite players like Serena, and some other players that are maybe at a different skill range or different experiential range, and that's I guess a little bit of the art of it. You can always strengthen it by having more data. So the more data, you can be a little bit more confidence, or have a bit more confidence in what's happening in the cluster, and the fact that the shot chains are successful because they're relating to those players. Relating to shots that are successful in that cluster, rather than successful because of individual players contributing to it. So the sample size is important. But also, and this is something which you can do in the dashboard, is you can filter who you want to exclude from which player samples you want to exclude. So if you're in R3 WTA, for instance, and you want to exclude Serena Williams, you just untick Serena, and you can basically generate the view based on all the other players in the cluster. But yeah, I think, and I'm probably going a bit circuitously in trying to answer it, but there's always an art element to it, to know the players, to have experience, to know what to look for, and of course there's improvements possible. You could bring in something like ELO ratings to add some other sort of contextual filter to help make sure you're picking combinations that are appropriate for the skill range. Fantastic, thanks guys. Alright, so I guess this is a little bit of an extension or part 2 of my presentation, and this is really focusing more on some of the use cases and some of the views of the dashboard itself. Let me just open up the dashboard. So I guess the landing screen on the dashboard, when you go into it, there's a couple of different buttons that can navigate to some important parts. There's a player page, I guess the main summary page, a little bit of the shot chain details, some segment views and shot chain views as well. Again, some of this is probably changing at some point, but that's what it looks a little bit like. Again, it's optimized for widescreen format. At some stage there may be a mobile version of it as well. So let's start with maybe the player page. The purpose of the player page is really to, I guess, get that sort of high-level look at the specific player. You'll get some of the I guess the biography statistics. If you want to visit their tour page, it's linked to, I guess, their ATP or WTA tour page. Now, noting not all players will have a profile, not all players will be playing, in the ATP, WTA, or even ITF. So there's a potential extension to try and get some of the profile pages from the other tours or other competitions, but at this stage it's just picking up sort of the pages from the main tour websites. You get some general sort of information, so their bio that they provided, I guess the classified forehand and backhand grip, so that we've actually just shown the dominant hand on the backhand in this case. And you also get some details on, I guess, in this data set we've got 15 matches of Serena. That's the amount of shots that are tracked. So you get that sort of information. Importantly, you get a little bit of information on the cluster itself, so it's showing which cluster she belongs to, some of the general sort of height and weight sort of characteristics and comparisons to other because she's the WTA player, so the other WTA clusters, and just a little bit of a look at the group makeup of the players in the cluster. So a couple of things, yeah, if you wanted to look at another player, you just select that. If a player didn't appear in the data set, there's this button here which takes you to a page that allows you to do that. And this is where you'd enter in the data. So let's say it's a female player. We've got a left-handed player. They've got an Eastern forehand grip and an Eastern sort of backhand or dominant hand on the backhand, and they're two-handed. And let's just say they're 155 centimeters tall and 60 kilograms. So they fall into a cluster, and the player doesn't exist in the data set, but we can infer that they're in this player cluster. This is based on the the clustering algorithm that I used. It had sort of using a random forest initializer. We were able to get some variable importance numbers. So this is created based on rules from that. So let's say L0 WTA, and in the player page now, sorry, not on the player page, any of the other views that you want to use, you're able to select that cluster and get some insights. I guess the second page, and I've called it the main summary page, probably title-wise it'll change at some point, but what that view gives is, well, it gives some guidance as to where the shots are being hit from the segment, where the ball gets hit to, a little bit of information around the split between whether the ball ends up on the deuce side or the ad side, short or deep. It also gives some information on the quantity of shots being hit from specific segments, forehand, backhand, what are they, and a lot of these things that you click on actually filter the view. I won't click on all of them, but you sort of get the idea, hopefully. If you select on segment 5, all the views, all the information at the bottom will change based on that. Equally, if you want to just look at points being won or something, and you click on this green one for the point filter, and that's giving you all the points that are won. Down the bottom here, you've got, I guess, the most used two-shot chains, the most successful two-shot chains, and the least successful two-shot chains. And in terms of how success and least success is sort of measured, I encourage you to listen to the first part of the presentation where we used a weighted outcome calculation that gave that sort of score. On the left here, there's a lot of filters. I'm not going to waste everyone's time by going through all of them, but basically, you can filter on player, you can filter on player cluster. You can look at filter on the hand that the player is using, the backhand type, single or back, the grip, the opponent's cluster, what hand the opponent is, and then also look at different just seeing things by segment. You can force the chains to look at just a specific shot first or specific shot second. A whole lot of other filters that you can use. Again, I've filtered a lot of this to look at certain shots, but if you wanted to include serve, you can bring that in. But yeah, I won't go through all the filters, but that's basically an idea of what that is. The shot chain detail page, now this is starting to show all the shot sort of combinations on the one page, and it's down the bottom, it's got, I guess, the top 10 and top worst 10 chains based on the selections. It's also got the individual shots that are contributing to a lot of the chains, which will be an interesting thing to look at. Again, you might want to just look at a specific player, so let's say Roger Federer, and then you've got his view, you've got his best shot chains. You might want to see how he does against, let's pick Rafa Nadal. I think there's probably only one or two matches in the data set, but yeah, you get a bit of an idea and a view based on that selection. And again, there's some filters here where you can look at, if you want to include drop shots in there, mixed chain would, I think, include serve and return and things like that. So different filters that you can use. You can force the chain to be a certain way. So I think the previous one wouldn't have filtered because I had the selection already in there, but if you wanted to have a look at other things contributing to the chain, you'll see, drop shot and a few other things now playing a part in that. Yeah, and if you wanted to look at a higher level, let's say we only wanted forehand to forehand in the chain, again, it filters based on that. Now this is an interesting one, which I allow the user to weight points that are won immediately versus eventually, and penalise points lost immediately. So if we were to weight, let's say we really wanted to weight the points won immediately a lot, you could do that, and then again all these selections will change based on the selection. Okay. So let's go back to the landing page. The segment view is, I guess the theme of this view is to look at the view from the segment's perspective. So it would be maybe to select, for instance, segment 5, and then you get a bit of an idea of, at a high level, what chains are being played, the outcomes. You can look at the detailed chains. You can look at which clusters are using that, hitting from that segment. We've got a lot of data from these two clusters, given that's where the data sets, the data that we have. But hopefully, in time, you'd have a pretty good representation across multiple sort of playing clusters. Again, a lot of these things you can filter by clicking on it, and it changes the whole view, and there's a lot of different filters here that you can use. You can also have a look at the next shot sort of location, so the next shot where you hit it from. So if you want to know where the shot chains that allow you to get to segment 5 in the next shot, you can filter the view that way. Equally, you might want to look at where the opponent is in between your two chains, so in between your first and second shot in the chain, or you might want to look at where the opponent will be after both chains are hit. So you might want them sort of maneuvered completely off the court. Let's say end up in position 2. Probably don't have a lot of data, so let's say in either 1, 2, or 3, and you can see that these are the combinations here, largely hit by a particular cluster, which is one of the ones that we've got a lot of data, allow players to be after the chain's hit for the opponent to be in a specific location. Finally, there's a shot chain sort of view. Again, this is now looking at it from the perspective of the shot chain, so you'll select the chain that you want to look at. Let's say it's backhand cross, forehand cross, probably an interesting combination, but it's obviously happening after, in between your chain, there's some sort of direction change, so you're hitting a forehand cross maybe. Again, more observations from a specific cluster, and you're seeing Roger Federer in the data sets actually hit that combination the most. But you can then sort of interrogate your data in different ways. You might want to go, okay, I want to see who's contributing to most of that combination from segment 4. You hit that and you see the dashboard sort of filter. And the other views are hopefully intuitive, like things like who's hitting the most chains, what's the most likely next shot, or the next shot from the opponent after the chain's used. So things like that I think were sort of useful things to look at. Yeah, and finally, I mean, this last view hasn't been finalised, but you can look at the you can maybe create a really simple view to just show the strengths that your player has. So you might select a specific player, so just to see, I guess, the strengths they have, the weaknesses of the chains that don't work well, or the ones that get them into trouble. Opportunities to explore. So this will be highly dependent on, I guess, your opponent cluster. So that's probably the difference between the strengths and the opportunities. And the threats is one where you pull the data from the opponent and have a look at, I guess, the threats that the opponent sort of poses. And it might be a simple one-page view to sort of view the shot chains in a way, in a scouting sort of scenario. But yeah, that's hopefully gives you a bit of an idea of the shot chain dashboards. There's probably a little bit of work still left to do to finalise it, but hopefully that pretty close, and it's something that can provide some benefit to, irrespective of whether you're a coach, you're a player, you're a researcher, and you just want to interrogate this data in a way that makes sense to you. I think these views hopefully allow you to do that.